we can measure at 2 meter. We can measure at 2 meter height. You okay?
Yeah.
Fantastic. Okay. So we can measure that at one height. So we kind of assemble that into one sensor. But the wind speed and wind direction should be per WMO requirements a lot higher. So we have wind speed and wind direction moved into separate sensor. The same we did with, of course, with rain gauges and additionally with agricultural sensor node, which is more and more used not only in agriculture, but in areas and in specified fields where people need the readings and the measurements of the soil quality, soil moisture, soil temperature, and so on and so on. Yeah. So we designed our system to be, well, I say it's fail-safe or foolproof, but my boss used to say, likes to say or use the word idiot-proof. And there's a great example for that, and I'm sure many of you who has ever been on an installation on site before can confirm that mistakes can happen. As much as you try, when the weather conditions are not ideal, when you're, maintaining or even installing weather stations, high winds, rains, you can maybe cut the wire short or drop an expensive waterproof connector. And after that, as a result, the debris, the water can get inside the data logger infrastructure, or maybe even the sensor itself. You don't have to realize it right now, but in half a year, maybe in a year or so, your expensive weather station doesn't work, and that's causing an issue, additional maintenance costs, etc., etc. So our approach was, we closed all the electronics inside. We have a magnetic on and off switch, which means it brings a positive aspect. You can do all the preparation in the office, in a clean environment, where there's no risk of bad weather or stuff like that. Turn on the sensor, put it on the mounting bracket, and that way you reduce the time on site, and also you reduce the risk of wrong or incorrect installation as such. Your technician, it's even maybe a student. Well, it's better if it's a student because free labor, of course. So it can then spend less time in field, install the sensor in 15 minutes, and move to another site. And as a verification, they'll just send you a photo. Okay, this sensor or this weather station was installed. Everything is good. We can move to another site. And this significantly cuts the maintenance costs and also the work costs, and prolongs the life cycle of the weather station itself. We know that this is one of the major struggles that net offices meet when they need to maintain the weather station for more than the duration of the project that they are participating in. So these specific photos are from one of the projects that we started with German agricultural insurance company. And they actually have a network of 735 weather stations. They are class 1 siting WMO network stations because there are playing fields. That means there are no obstructions, and the struggle, actually they have higher quality data than the German Met Office, and the German Met Office are now in the talks with them because they want to acquire the data and use them for their own purposes. The reason for that is Met Offices, well, they don't own land, of course, or even the weather station that have already installed in the past are built up by houses, infrastructures, roads, that eventually affects the quality of the measurements that they propose. Farmers, on the other hand, they have plenty of land. They can maintain the land around the weather station, and in return, they can get forecast, they can have the data for pest or disease control, or lots of things that they can benefit from. So these insurance companies, they buy or even rent the weather stations to the farmer, and the farmer's benefit is, of course, that in case of crop damage, they can get a quick payout because they have a weather station inside, in field. biggest advantage. So there's a lot of synergy between these partnerships because each side eventually benefits. So, as I've said, of course, I'm sure that there are many countries in Africa, of course, that have early spring frost and stuff like that. So, PVPs with climate can definitely provide agricultural land and basic while stations provide hyper-local data. Yeah. So the benefits can be frost alerts, the benefits, disease risks, also irrigation guidance. Irrigation and water is an issue everywhere you look, not only in Africa. It's a world risk. So, and community engagement, of course, boosts data use and the resilience as such. Yeah. So, the way we built up this network is with LoRaWAN technology. I don't know if you're familiar with LoRaWAN, but to put it in simple words, it's long-range wireless automatic network. Sorry. It's hard to put it into mouth. So these are the frequencies lower than Wi-Fi connection. That means that we can drain the power consumption to the ultra low level, and that way these sensors or weather stations have a longer life cycle than they should have. Yeah. So with this LoRaWAN technology, you don't need to use the data logger, you don't need to use the wires. The only thing that you need are wireless sensors in field wherever you need them, and a gateway, which basically acts as a Wi-Fi router or Wi-Fi modem. Yeah? And with that, based on the signal coverage, you can create your own signal coverage where you install all these weather sensors. So even if you don't have a GSM signal, for example, at the edge of the GSM signal, you install one gateway that can cover 15 kilometers square, which basically ultimately creates for you 300 kilometers square of signal coverage, and in that 300 kilometers square, you can install the weather stations or singular modules as much as you need. Yeah. So on top of that, you can have each of those modules installed, as I said, wherever you need, and without the need of building the whole weather station. These are modulars, so each of those sensors work separately, communicate separately. Yeah. You can measure temperature, for example, at 10 places. Rain, you can measure at 5 places, and wind at 2 places. It's totally up to you. And that can save costs because you don't have to build full weather station in each and every place. Plus, that way, you are optimizing your network for specifically your weather patterns, while the measurements and the quality of the measurements are not compromised. All of these sensors are WMO class, have WMO grade class accuracy. So as I mentioned, we cover all the basic parameters, all the standard parameters, and we do it right. All the way from wind speed, wind direction, air temperature, humidity, pressure, and rainfall, all the way down to the metal AG IoT, which is, as I mentioned, for soil measurements, yeah, soil moisture, temperature, leaf wetness, and so on and so on. Of course, in the works, we do have hydro height, which will be a water level sensor, evaporation pan, meteor outing, which will be multiple pressure sensor for civil aviation. So yeah, there's a lot of things coming up, and that is the sole reason why my CEO isn't presenting right now in this very moment. So yeah. Oh, sorry. Okay, so the cost efficiency. We're talking about this German agri-insurance company, so they have this specific project relies on 735 weather station, and the annual servicing and maintenance was only 22,000 euros, which I think, from my perspective, is definitely a game changer, not only for Meta offices, but for private customers as well. Because you can basically fill in the gaps between your large AVOS weather stations with compact micro weather stations that still maintain the WMO grade accuracy. So one of the things that helps us cut cost is, again, the interchangeability between sensor. So thanks to the price affordability, if by any chance one sensor fails in field, You still have the remaining sensors working fine. You send the technician in field, he replaces the sensor with the buffer stock, he comes back to the office, and in clean environment, he can service, inspect, disseminate the sensors, see what's up, see what's looking down, contact the tech support or the customer support from our part, and move on from there. So that immediately saves not only work costs, but also the maintenance costs as well. This should have a video. I don't know if I can turn it on. Can I turn it on, Katie?
Yeah.
Maybe I did that. And I forgot how to do it. Okay. Thank you very much. So this just shows that down there, there's this weather station. These are just two modules, as you can see. Only the metal helix, the micro weather station, and the rain gauge in one place, which means ultimately they can literally be installed anywhere you need it. I know that there's a question of theft. So theory, in next 6 to 12 months, we are going to add the GPS module into each and every sensor. So if thieves are there, they will definitely be caught. And believe me, no one will ever know how to turn on or off the device until it breaks it or destroys it. And that way, he has no need for that weather station. So in here, I had an interesting study from Honduras. Specifically because of the climate smart agriculture. That's how they call the project. They are basically monitoring microclimates of different coffee farmers. And the reason for that is they are studying whether the coffee farming will be sustainable in the future or whether they will have to switch and move to different crops based on the hard data they have from weather stations. Yeah. They use Davis, they didn't use our sensors, but either way, you get the point, and I think the message is quite clear. So we need to study, we need to analyze, we need to do more in order to adapt to the foreseeable future. So in conclusion, toward the resilient data-driven Africa, we need hyper-local alerts that reduce disaster losses. Climate smart agriculture improves yields and food security. We know for a fact Africa is heavy on agriculture. We need that data. We need to analyze it, and we need it more. That way, we can create sustainable, scalable network with easy use, with easy maintenance, with low maintenance costs, and with hard data that will be affordable for everyone. We definitely need to create more dense network with standard measurements, with standard basic measurement stream. So low OPEX frees, of course, budgets to expand coverage rather than sustain it. And this is only possible if the maintenance and installation costs are within the reach of each respective Met Office, not only the rich ones. So in conclusion, yeah, that's the video as well. It's just that, yeah, it's just an example of our rain gauge. We did a hard foolproof testing that could measure 2,000 millimeters per hour at rate video. Of course, there are splashes. Nature cannot do something like that, but we are trying to replicate harshest conditions for the rain gauge. So in conclusion, I would just like to say thank you very much. If you've got any detailed questions, I would love to answer them by our booth or by roundtable discussions we are going to be moderator of. And thank you very much for your time, and hopefully we'll see each other.